Good morning. Today we will demonstrate how to get very good quality, balanced steady state free precision or TruFISP images on subjects or patients with multiple sources of artifact. In this case, we have a pacemaker, pacing leads here, pacemaker up here, sternal wires, and a metal aortic valve, so a heavy burden. Anyway, key considerations before you start. You have to think about how you're going to avoid the artifact or to get rid of the artifact. I have deliberately put the field of view lines here and the shim here so I can show you how to place the shim and what type of shim to use. Let's get cracking. So I have my localizers here, my 2-chamber localizer, short axis localizer, 4-chamber localizer, and then I copy my adjust volume to my short axis. I then make sure that I make it as small as possible, only to cover the left ventricle, and I do that on all 3 planes here on the 2-chamber, 4-chamber, 2-chamber, short axis and 4-chamber, avoiding going into the sternum or sternal wires and avoiding the pacing leads as much as possible. Field of view, make sure that the field of view is small. In this particular case, we've used 220 field of view. And what I've just done here is make sure that the shim is a cardiac shim, and I've put it such that we get our peak to make sure that we have an adequate peak for the shim. 220 field of view here. And then our base resolution of 1424 with interpolation, and then our temporal resolution will be 39 milliseconds, so a high temporal resolution. Let's just move this out of the way. So all these copy preferences, I've made sure that I just copy the shim from the first one, in this case the 4-chamber. I've also made sure that because of the thing, there's our peak. We've got a nice peak for our shim, we'll apply that. And I've also made sure that it's a very short breath hold, in this particular case 6 seconds, which will allow me to do 2 slices per breath hold. So the shim is copying now, and then our 4-chamber stack will run. Here's our field of view. Shim has copied. We're planning the 2-chamber now. Small field of view again, 220, with 38.92 milliseconds temporal resolution. First slice of the 4-chamber and second slice, and there's our metallic aortic valve and our sternal wires here. Breath hold time for this one is 7 seconds, only because we have an oversampling of 140% of the 220 field of view. 7 seconds is still reasonable. No compressed sense on this. For the 4-chamber stack, we didn't have a phase oversampling of 140, it was only 100, which meant that each breath hold was 6 seconds, but I've done this at 2 slices per breath hold. The reason I'm doing stacks is I also want to demonstrate the mitral valve well, as this patient has got mitral insufficiency. And there it is. You'll notice we're throwing away all the artifact. It's artifact free. You still have obviously the aortic valves here and the pacing leads that you see here and the sternal wires, but your image is of very high quality. The shim, remember, has to be tiny. It shouldn't cover all that. The bigger your shim, the worse the outcome that you will get. and it's demonstrating appropriately the anterior and posterior mitral leaflets. And then obviously you've got the pacing wires that you're seeing there. The stack is going through quite nicely. Very high quality. No need to do flash on this. Obviously you will get once in a while patients with probably defibs that will have so much artifact that you may be forced to do these views as flash sequences. However, in my personal capacity, I've hardly ever had to use flash. I always have to use the TruFISP and they come out nicely. Now I've paused it here so that I can show you the angle that I'm using here for my field of view. I am angling to my anterior chest wall and I'll move this anteriorly. No need for all that, the spleen and bits like that, unless of course you are doing stress perfusion. That way you can look at the splenic still so you know that the adenosine is working well. Now, the other reason for angling like this is so that you can optimize your oversampling and make sure you don't have any phase rep, and also to avoid the artifact coming from the pacemaker above. We'll carry on. So we're planning our short axis stack now. The shim is the same, it has copied still. And we'll just align it to the mitral valve there so that we get the mitral valve in plane. So 14 slices, 7 breath holds, and each of them will be about 12 seconds for 2 breath holds. Now this patient manages the 12 seconds per 2 breath holds. If not, you can always reduce that. And the reason that we can manage to get such a short breath hold is because of the field of view again. There comes our 2-chamber, very high resolution, free of artifact. The artifact is up here from our pacemaker. Excellent quality 2-chamber view. And then we shall start our short axis view now. You're getting good pulmonary veins and good atrial appendage here, and of course good myocardium here, good chamber, good mitral valve. Now here come our first short axis images at 2 slices per breath hold. And then there's your aortic valve, and then again pacing wire, sternal wires. Now we're going to increase the slices in order for us to cover all the way from the posterior to the anterior mitral insertion points, and we will use in this particular case our short axis views that are coming. And here we go. And you can see the mitral open and close here. And again, we will use, here's our mitral here, 2 slices per breath hold. So we've got 8 slices here, 4 breath holds, and each to be 10 seconds per 2 slices. Shim is the same, we haven't changed it. And you can see here the dancing pacing wire in the right ventricle. Earlier on I'd done the white bloods. Again, good quality white bloods. Despite all that, this will be for another tutorial as to how to get good quality white bloods, even though you've got the pacemaker and all that metal artifact. Let's just skip to, as we've already demonstrated, the short axes are working well. Let's skip to our 3-chamber for our mitral valve, in plain views of our mitral valve. And here we go. demonstrating our aortic valve there and our mitral leaflets there. And here we go, your anterior mitral leaflet, posterior one, well demonstrated. For the aortic valve, we have no choice but to plan it as flush, as we are right on the metallic valve itself, but we'll increase our slices to 5 slices and go up to our STJ, which in this case is not as definitely clear because of the aortic valve replacement. The shim remains the same. And then we'll run this. Each one is 10 seconds again. We've just done a manual shim just to demonstrate again that the peak is still good. And there's our first slice over here. I tend to do the slices in this particular case starting from well above the valve to below the valve. Again, good quality even with the sternal wires, not sternal wires here, and pacing wires there. And then now in this case I'm just planning my 2D phase contrast flow above the metal artifact, because if you plan it on the metal artifact it will degrade the image. I'll just fast forward a little bit to get to the 2D flow. And in this case also you can see the actual valve here, and again sternal wires, pacing leads, and more pacing leads, but again overall good quality. This is our flash sequence of fast low angle shot. And then let's just fast forward to our 2D phase contrast, and there's our 2D phase contrast. And then after that we shall plan a sage oblique of the aorta. We won't use flash, we'll stick to our TruFISP of 5 slices, and our phase encoding will be A to P, but obviously the usual way you plan it, it's away from the pacemaker and away also from the sternal wires. 40 milliseconds, your temporal resolution. And in this case here, I'm not too concerned about ghosting as much. I'm going to use 2 averages or superimposition of the slices. It will just improve my images for my sage oblique of the aorta. And it will I'll still maintain the short breath hold times. 8.4 seconds. That's again due to our field of view. Even though we've gone up to 340, we've maintained a good matrix size on this. And I'll just fast forward to that. And here we go, our good sage oblique aorta. And in this case now we're planning our real times for our access. Again, we'll use the same shim. We need to look at our sternal axis. But whilst we access views here, so we've run 5 slices of it, and there are your sternal wires. The idea is to make sure that as the chest moves up and down, it does not pull the heart with it. And in this case, clearly no adhesions. This is very helpful for surgeons as they go in. Real-time sternal axis. Hope this has been helpful. Thank you. Scan by Stephen Miribidi from Transform MR.